full disturbance will come. Full more disturbance. And this upset work when it started? Today or today only? Huh? Okay, we'll see. Linear algebra we will see. Huh? I increased sound there. Huh? More sound means tell me. Close. The linear algebra full of linear portion we have to see here after. Already 90% work we finished by the help of matrix. Matrices, whatever concepts we saw, that and all basic of linear algebra. Whatever linear algebra portions are there. In this we have to analysis about vector spaces, and in between for vector spaces we need matrix and all, some concepts and all, so we have to use here. Linear algebra nickname is branch of mathematics. Sometime interviews and all asked. Modern algebra is a field of mathematics and linear algebra is branch of mathematics. So here we will discuss about vector space definition. And vector space, when we are reading, then we need here field, because always you will see vector space over the field R, over the field C, like that we are reading. Over the field meaning our vector space means what? Collection of vectors, and vectors are dependent on our field only. arranged from real number, arranged from complex numbers, either single, double pair, triple, whatever n tuples are there. Each and every elements from real number, each and every elements from rational number. Okay? We will see. Vector space definition. Vector space or linear space also telling. Habit not going. Heading. This heading I will cut then. Already morning itself too much disturbance. My mind not working hereafter. Okay, won't cut because already I gave definitions. I thinking I will write again or not. About binary operation definition already I gave. Binary operation and external composition and all. Binary operation I gave. Then cut it. External composition not giving, no. External composition, internal composition. Then enjoy hereafter. Binary operation, these are just basic definition. This already I told binary operation means binary operation, kernel operation, both are same definition. These are closure property, closure law, which is star of AB is equal to A star B must from G. For all AB belongs to G. External composition means two element operation in that one element from other non-empty set. So A star alpha is belongs to G, where alpha belongs to G, and A from other non-empty set. And that non-empty set sometime filled if going on, then we can tell scalar composition also or scalar operation. This only we have to use in vector space. Group definition and field definition I am not writing. That and all we will see on modern algebra. Group definition already you know, closure law, associative law, identity inverse, and for commutative means abelian group. So field definition is also under addition abelian group we need, under multiplication we need abelian group. Actually here we need for vector space two operation, addition and multiplication, and under addition we need abelian group, and under multiplication we need closure law. Must closure law will satisfy. Enough. So vector space means under addition abelian group and under scalar multiplication closure law satisfied. Little basic we will discuss, basic examples. So just you think your non-empty set is n cross n matrices and increase from real number, then V is vector space over R minus Q or not? Yes or no? Something you told. Tell. Then what? Then what? If not filled means what? Another anybody? Satisfy abelian group, but for you telling anything, money have to pay? Anything have to pay, then tell I will pay and I will ask answer from you. Then always, you know answer, you won't give answer. You tell anybody? She told abelian group possible, but not, I think not second property won't come. That telling. Means half I have to complete. Abelian group not possible. Because this is not vector space. You are telling another. Tell. What telling? The entries are real. Anything I will multiple. Real only will come. No. Root 2 or anything. Matrix entries are root 2. Any irrational number I will addition, I will do multiplication, I will do. No problem. What is this? Entries are real number, no? Why root 2 into root 2 thinking is R minus Q?
Sir, irrational numbers are not filled.
You are telling correct only, but no, you are getting confusion yourself. And another concept telling here. R minus Q is not a field. This question is wrong. Finish. We want over the field F, no? What is F? R minus Q is a field? No. This is not a field, so this is not possible. Question is wrong. Another reason giving. You told starting correct. Also silent mode. God only listening. Loudly tell. This question is wrong. R minus Q is not a field. Why I can write? How I can write like this? Okay. Okay, hereafter, no problem. Both are filled. Hereafter, tell this is vector space or not. Very basic definition means just we are remember doing what we did on BSc, MSc, vector space. Just little bit mind fresh. This is vector space. We are BSc have or not? Vector space next semester have. What semester now? First. No. What is your semester? Second, third? Which semester you are going on now? Fifth going. Sixth semester this have. That is maybe last semester. Your this got or not? In future, if I will become education minister, no, first I will damage this semester. No semester in our country. Semester. It's BSc first day you have to think this and all. Matrix, linear algebra, everything. Another anybody what hereafter you tell? He told vector space. You? What another anybody? Roshika? Shyam not tell. You are giving answer always correct. Tell. Explanation not correct, but answer is correct. Vector space. Satyasri, why hiding type sitting? Here sit. I can see, no? Here sit this fan on. Both come. Jonathan? Don't know. This and all basic, no? You can see also BSc and all.
Sir, is it not a vector space?
Not vector space, yeah, I'm telling. Why, Shyam?
Sir, it is not an external composition.
Not
External composition.
second property. Okay, you explain. Shyam told no. You tell how external property not satisfying. What take? Will take, not take. Why I will take? You take. Will you take? You tell what scalar I will take. 2. Root 2. Oh, okay. Root 2 after that. Root 2 not. Then root 2. There something have. Oh, notebook have. Oh, okay. I don't know books anything have. Root 2 into. Why root 2 into 1 by 2 want? Matrices we are reading. Matrix don't want. What is this example? Root 2 into 1 by 2. You will tell. Satyasri tell. This is vector space or not? Shyam told no. What is your opinion? Vector space. What is your name? Raghu? Vector space. Shyam telling no. After Shyam telling, she told no, but example correctly not giving. I want correct example. No, you are anything telling any scalar will any not. You have to tell that scalar properly. This is not a vector space. Old student especially wrong telling. That is not acceptable. New student, wrong telling, no problem. Old student, not acceptable. Entries are rational and over the field are given. Any place, no, in future on exam hall also asking which of the following are vector spaces or not, like that question they will option they will ask, or subjective exam also have. First you verify to second property under addition abelian group and all, don't check, always check it. You try to find your counter example from scalar multiplication. 99% you will get from there. Not getting, then you can come on under addition abelian group property, any contradiction is there or not. Here our entries are rational have. Means A belongs to V. Then in this meaning, whatever entries are there for all Aij is rational number. And we have to prove over the field R this is a vector space or not. So second property direct we will see A alpha means this is A belongs to V or not. Question mark. A is equal to root 2 I will choose and I will multiple with A. So can I tell that root 2 multiplication with every entries Aij, then this is all entries are rational? No. Root 2 multiplication any rational, that is not rational. So this is does not belongs to V. Like that I have to do. Root 2 into 1 by 2 not. This is matrix collection. Okay. So this is the counter example. So this is not a vector space. Suppose entries are from R and I am changing box. Two notation I gave. Question I can't write every time. So entries from R and over the field C vector space or not? Question mark. Next question. Same things. Vector space. No, not vector space. Why? Yes.
Same reasons.
Yes. A is equal to iota I will choose and I belongs to I into A. I into entries multiplication with Aij. Aij real entries. So this does not belongs to B. So this is not vector space. In this case also. Suppose entries are from irrational and over the field R. This is vector space. R don't choose. Over the field Q. Vector space. No. Not vector space. Vector space. You tell us anything. Your BSc completed novel semester. Vector space. Deepak, vector space.
Well, not a vector.
See, I'm telling not vector space. Why Shyam counter tell?
Sir, it is not closed under internal composition.
With his scalar means second property does not satisfy. Same type you are
Yes,
telling.
sir. Yes, sir.
Example, what is that A?
Sir, just a second.
No problem. You take time. Here somebody told, no, anybody no told? No, tell me example tell. Here what? Both are direct, sorry, and taking outside. I can't do. Think little. You told, no, not vector space. You told, the silent living. Tell example. Why no? What is that? Example, A, what is A? I gave here A is root 2. Here A is I. What is A here? E.
Sir, root 2 0 0. 2 cross 2 matrix.
Root 2,
Root 2 0 0 0.
root 2. You are telling about matrix, you are telling.
Matrix, yes, sir.
Root 2, 0, 0,
0
0.
0.
Okay, Miss first row is root 2, 0. Second row is 0,
Second
0.
is
Okay, he
0.
told matrix. What is that scalar value? You will multiple. This meaning this is from V.
Sir, the same matrix. Root 2
What is
0
that
0.
A? A is root 2.
No, sir. Root 2 0 0 0. The same matrix. Internal composition.
Oh, you are telling that, then you are telling first property.
First property is abelian groups. V comma plus is abelian.
Then second property, how matrix can take? Second property means A is a scalar we need.
No, sir, but the second property says V comma dot should be closed under multiplication.
First question you understood or not?
Yes, sir. Entries is from irrational
Entries
number,
are from irrationals.
and we should prove it. Try to
Over
prove
the
it is
field
not.
Q.
Okay. Okay.
This box means entries. This
Uh,
meaning over the field Q. Means V of Q, we need vector space or not? What you told Deepak? Now correct. Shyam answer is correct, but explanation not giving correct. Your answer correct, answer not giving correct. This is not vector space correct answer. Okay, but you choose here root 2 root 2 you choose. Under addition we can go here. Under multiplication don't go here. Under multiplication you can't get contradiction because any rational means A belongs to Q if you will choose any type of rational that will multiple with A, and A means Aij. Aij is irrational. So multiple with rational, that will be the irrational only. So you can't get contradiction from scalar property. We can go, he told, I will write here. Just root 2, root 2, root 2, and another one matrix, just negative you choose. And addition we will do means null matrix will come. This much also no need. Direct we can tell additive identity does not belongs to means P under addition abelian group not possible. Closure law also won't satisfy. Identity also not there. Okay. So this is not vector space. B is not vector space. I have no place here after. Write everybody over Q. Question understanding box means entries and over the field dash. Huh? So little you can write or like that notation can give. Any problem with you? What tell? Huh? What is? You came from Mars or another space? From Earth only, no? Oh, feeling like that, no? It came from Mars. India is the first country in world, the first attempt to reach the Mars. Maybe by that space you came anything, that spacecraft. What you told field and abelian group. 11 class, 12 class also abelian group definition. Abelian group is just a 4 property have to satisfy closure law. Yeah, A into B into C, A into B. Before can tell a group property definition, I will write one time. Wait, group property, I will group definition, I will write this right first. That time itself I told this and all, no, for that I'll neglect it. is just you think our mind some what telling automatic coming no virus and all we are deleting chunk we are deleting over the field are entries from C entries from C over the field are like this. Okay, you write group property, group definition I will write. Finished. Right first. So group means four property have to satisfy: closure law, associative law, identity inverse. And when commutative law will satisfy, then that is called a abelian group. Not satisfying means non-abelian group. Okay. This definition again I will write on modern algebra time. And field definition I gave on real analysis. No? Field is just under addition same non-empty set we need. And field means under addition abelian group, under multiplication abelian group. When under multiplication we are choosing, that is a non-zero numbers. Okay. This is enough. We will see on modern algebra for field whatever we need. Group there we have to read, ring we have to read. After that field. So vector space also under addition abelian group we need, and under multiplication just associative law with that, but that multiplication will be external composition. Means your one elements from field F. For that scalar multiplication also telling. And whenever in life, no, and same this group property our life also satisfying. Whenever any group making, this core property must have to satisfy. Otherwise group does not exist will come. Automatic that group will damage. If one property won't satisfy means group break. New group will come. Understanding? Must will satisfy. You can try in your life whenever making group. Must for property not satisfying anyone, must that group does not exist will come. Must. Either in a school, college, university, any place you see. And you have experience also. School, college, this only first work. 2 student group, 3 student group, 4th student group. And here also, in our institute also, I am telling no discussion start. Make a group and discussion start. More group eyes of height also went here. Because of height, I sometime I stopped discussion class. Hereafter, no discussion class. Very bad type fight went. With so see, understand, and then make a group. Either you can make yourself also. Only one element. You can make with two elements. Means two friends. You can make with three friends. You can make with four friends. Understanding? So you can feel whenever you will make group, you will feel if disturbance means that group does not exist, one day will happen. Okay? Must satisfy. Then group property extra you will understand. Next we will go vector subspace. Okay? We have more example in between we will see. I will give more properties how to verify vector space, vector subspace, everything. This always keep in mind what is the entries and over the field are. These two if you will catch properly, then only you can proceed vector space or not. Sometime m cross n matrix will give, sometime n cross n matrices will give, square, non-square, anything they can give. Nowadays not asking, but like this question possibilities are there. Vector subspace we will see hereafter. Some that basic otherwise one time, right? Right first.
பதினஞ்சு சேர்ந்துருக்கு. போலாமா?
Finished. What happened? Huh? Then why writing? Don't write. Is anything I will write, you will write. Natural number is filled, then why writing? Cut it. See, here a good looking will come. If anything I will write, you will write. N is not a field. Huh? Cut it first class. Design with design. Red pen use a black. So real over the field R means real vector space, complex means complex vector space, rational means rational vector space. Finished? Cut that is, don't forget, otherwise later you will revise. Natural number is not a field. So vector subspace means just subset of V, and that also vector space means vector space property will satisfy, then that is called a vector subspace. But we have no time on exam hall this much that on every property we will satisfy. We have options for vector subspace. When vector subspace have, you are going to verify, then only two properties satisfy enough. Vector closed under addition and closed under scalar multiplication. If these two properties satisfying means, you can tell that is the vector subspace. No need under addition, abelian group, everything. Only these two property enough. We will take help by this theorem. Any W is a subspace of V if and only if W is closed under addition and under scalar multiplication. I will prove also. This is easy proof only, and but important proof. Okay. See, first necessary condition I will do. Right. You want to write later, I will explain. Right, everybody. I have no place. You write first. Finished. So Necessary condition means W subspace given have, then we have to prove W is closed under addition, under multiplication or not. So when W subspace given have, this meaning W is a vector space. So under addition closed, under scalar multiplication closed only will happen. So proved. Sufficient condition means just converse. Means if W is closed under addition, closed under scalar multiplication, then W is vector space or not. So I taken helped by the equation 1 and 2 and I proved everything. Editing, additive inverse, identities, commutative laws, and this is the abelian group. So finally W is a vector subspace over the field F. So any place subspace verification if you are doing, then only two property here after satisfy. Under addition closed or not, under scalar multiplication closed or not. If getting your contradiction, then not vector space. Not getting vector space. No need to think complete addition, under addition, all properties and all. But if vector space writing, then you have to satisfy all properties. Okay? Not for subspace, only for space. By the help of this theorem, another some properties are there. So this also two property coming from last theorem only. Just together writing A alpha plus B beta means scalar plus under addition closed together, or A alpha plus B beta, A alpha plus beta. So exam hall or any place verification doing means separate also don't want to show means A alpha plus B beta belongs to W means that is a both property satisfying. Any type of subspaces, three type of subspaces if you will see, when W containing only identity. And identity means additive identity will contain. Here two operation have addition, binary operation, and multiplication is scalar multiplication, scalar operation, external composition. So under multiplication identity, we no need. Vector space identity is there under addition. Means any subspace containing at least one element, that element must be additive identity. Okay, so zero. For that, this is called a zero subspace. And another name we can tell proper trivial subspace. When W is itself, in this case, we will tell improper trivial subspace. And when W is neither identity nor V, then proper non-trivial subspace. These three name always frequently we will see. On subgroup and all also we will see, when group theory we will read. So proper trivial, improper trivial, and proper non-trivial. Trivial word already we discussed, no? Trivial element, non-trivial element. Like that here also behavior. When itself is there, identity is there, means that is under trivial will come. When both are not there, then non-trivial will come. Tell me vector space, subspace or not. This is your work. Everybody verify. And what have to verify? Only two operation verify enough. Sorry, two property. Under addition closed, under scalar multiplication closed. In that also no, always under multiplication first try. Not getting, then under addition. Right. Finished. I will do.
Sir, 2 minutes, sir.
2 minutes. Okay. Okay, Sam, you do. But finished. Okay. Right. 2 minutes. I will wait. Sham also 2 minutes want. I will wait.
Sir, done, sir. I will go next. Sham complete. Yes, sir.
Then tell first is vector space.
Yes, sir.
This is vector space. This is vector space. This is not vector space. This is not vector space. This is not. Correct. Everybody check it.
Yes, sir.
Huh? Second at telling. Okay, checked everybody. Leave it here after. I will do then check it. Wait. First, on exam hall like that question must one coming every exam, CSIR exam, IIT JAM exam, UPSC exam, is still asking. One question must come in. Which of the following vector subspace of V of F? Two type of concept always keep in mind. First, whenever I am writing like this vector space, what is the meaning of this? W is equal to A comma B and such that A plus B is equal to 0. This meaning that which AB satisfying this, that AB collection here. This meaning W is a solution space, solution set, space not, space we have to verify. Solution set of this type equations. Okay. So always minimum two type of equation you will see, homogeneous system of linear equation and a non-homogeneous system of linear equation. If homogeneous system of linear equation coming means must subspace. Means W is a solution set of homogeneous system of linear equation, then W must be subspace. I will write. Because homogeneous system giving two type of solution. Unique solution and infinite number of solution. Unique solution means 0, 0, 0 means 0 solution and infinite number of solution means infinite, k into something like this. K is arbitrary. Time we are writing arbitrary scalar. Here we will write whatever field is there. If field is R, K belongs to R. Field is C, K belongs to C. Now our matrix theory and vector space, these thoughts we have to change. Their matrix collection of numbers. So scalar, 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 arbitrary number, anything we can write. But hereafter depend on everything field. Whatever overfield R, overfield C, that time we will decide K belongs to R, K belongs to C, entries from real, entries from complex, like that decision we will take. Okay. So when we have homogeneous system of linear equation, then either zero solution will come or non-zero solution, infinite number of solution will come. Infinite solution means like that will come. Correct? K is the over the belongs field F. So when only zero solution containing, this means that is the only identity, trivial subspace. Must vector subspace we can write. All property will satisfy because zero only have. Under at 0 plus 0 go or A into 0 go, 0 only will come. When we have infinite number of solution, what is K? K belongs to field F. So here K is 0 also you will put 0 solution will contain, non-zero you will put non-zero solution will contain. And property of vector space must be satisfied. Or vector subspace we have to verify. So two property only, under addition closed, under scalar multiplication closed, must will satisfy. So whatever homogeneous system have, direct take out. Must vector subspace, must vector subspace. But when we have non-homogeneous linear equation, non-homogeneous means never vector subspace, never. Because there are two conditions have, solution will exist, otherwise no solution. If no solution means no vector space, no need to think solution. Suppose they define this is non-homogeneous. If suppose solution not coming, no vector subspace. If existence is there, if solution is there, then two cases will come. Unique solution and infinite number of solution. And in non-homogeneous system, unique solution means non-zero solution. And infinite number of solutions are also non-zero solutions. Because of that constant. Always I told that infinite number of solutions are always constant term will come. K plus 1, K plus 2 or 2K plus 1 means K, 2K, 3K plus 2. One constant term must will come for one vector. And because of this 2, whatever K 0 also you will put means non-zero only will come, 0, 0, 2. And already I gave in matrix theory, non-homogeneous system has only non-zero solution. When solution will exist that time? Only non-zero solution. Zero solution never possible on non-homogeneous case. But not giving. Yeah. No. In answer key you are telling wrong have. A last exam test telling. Which question? Question have? I gave in notes also. Now I question maybe answer key also typing mistake maybe possibility have. Huh? Answer is correct. No, I am telling future also. Maybe answer any typing mistake have, tell me. I will discuss with you and correction possibilities are there. You check it after evening time or tomorrow and I'll check. But I gave in notes also the non-homogeneous system of linear equation, whenever solution will exist, that solution always non-zero solution. Zero solution never possible. Okay. So when solution existing and solutions are non-zero, then also never vector space, no? Because we need zero vector identity is not there. If I will tell V is like this, this one W, if I will tell collection, if like this collection, K, 2K, 3K plus 2, then this is vector space or not? Not vector space, because zero identity is not there, 0, 0, 0 is not there. So whenever non-homogeneous system solution existing, also non-zero solution only. So never non-homogeneous defining means direct cut it to, never subspace. Okay. For this I cancelled a homogeneous system of linear equation. B direct A is equal to B equal to C have. So A. This is non-homogeneous. This is non-homogeneous. This is non-homogeneous. This is homogeneous. This is direct C equal to 0 only. So direct we can tell. These are I will explain later. So homogeneous, non-homogeneous cancelled I did. Non-homogeneous cancelled I did. Homogeneous direct take out I did. On exam hall also you have to do like this. We can save our time. Here these are just unnecessary talking. A plus B less than C. So we can go by our second property. Just this we can write. Okay. Means you have to choose ABC from here. Suppose alpha I will choose 1, 1, 4. So their addition A plus B. Yeah, direct also we can tell. 0 is not there because 0, 0, 0 means 0 plus 0 less than 0 we can't tell. Direct that also we can tell. We can tell that 0 vector does not belongs to W. So not subspace. Or if suppose I am going by property, then how to satisfy C? Suppose here written have A plus B less than C. So I choose like this 1, 1, 4. Their addition less than will come. Scalar multiplication, what I will choose does not belongs to will come. Scalar, I think any type of A multiplication I will do. Yeah, minus case we can go. Positive case less than only will come. Minus 1 itself take. Then A alpha will be minus 1, minus 4. So here after minus 1 we will add means minus 2 will come and minus 2 is greater than minus 4. Same we can proceed here also. Suppose alpha I will choose here written have A is between minus 1 to 1. Means mod less than 1. Suppose I will choose 1 by 2 BC and A choose 4 itself. A is equal to 4, then A alpha will come 2, 4B, 4C. So 2 is the greater than 1, not satisfying this condition, so does not belongs to W. Like that contradiction thing. What is the A, what is the alpha, and one line you can give answer. No need all properties. Okay, like this contradiction you think. Here already C is equal to 0 here. This meaning this is A comma B comma 0. This is first class vector space. Okay. Right then. Already you did maybe. Just whatever explanation I gave, that the two concept I will write, that don't write. If you want to write related any concept there, you write. Theories I will write next. Which of the following are false? I will write. We will discuss when question giving means. Hmm? Anything want to tell? Here, which of the following is are false asking? AX0 has always consistent. AX is equal to B has always non-zero solution. If existing solution, AX is equal to B have exist always infinite number of solution. AX is equal to 0, exist inconsistent. False asking. What problem for you? Tell first. No, if exist solution just last I wrote, comma have means if this non-homogeneous existing solution, then that solution is always non-zero solution. So this is true statement. True statement, then why false? Here false given have.
C false, sir.
You are thinking like this. Means B is 0 also possible.
So C and D
AX
false.
is, what version is?
C and D false.
C and D false. AX B has exist infinite number of solution. First no, then I will change little bit in question. My target was B is non-zero only. B is 0, don't think. I will add in question, this is hereafter. Correct. And CD what given have? CD false. No, B not equal to 0, you write there in question also. I will change. AX is equal to 0 has always consistent. This is true statement. Huh? AX is equal to B has always non-zero solution if existing solution. This is also true statement. B is not equal to 0. AX is equal to B exists always infinite number of solution. No. And AX is equal to 0 exists inconsistent. C and D right. Answer ki B given have. I am thinking what I thought and gave answer. Maybe I was thinking also that B may be 0 non-zero. But now I am thinking B non-zero means first test no, just basic type I prepared. C and D right. In question if possible little changes to in notebook and all. Be non-zero. I will change in question also. This much on first test, don't think. You think, means don't think means I'm telling some students will get problem. Okay then A and B is true statement, so we can't take out. False statement asking. So C and D will be the false statement. Maybe I was thinking also B is 0 non-zero, for that I put. But now in my mind running that B not equal to 0 only. Yeah, you are thinking correct only. B is 0 also possible. And define not have means B 0 non-zero both possibility. In both case have to see. If not define have means both you have to think only. Okay, now clear. No. Take series questions, discuss together and finish. Don't miss this and all. Next again, write again, tell me. Finished. I will do. So, tell what vector space telling first vector space. Second, not vector space. Third, fourth vector space. Fourth, not vector space. 5, 6, 7. Okay, we'll see. What you told, I did. First is not vector space. Closure property won't satisfy. A and B, if we will choose from here, A comma B belongs to W. This meaning both determinant is 0. But their addition, determinant must be 0? No. Two singular matrices, their addition singular, who told? This is less than 0 also possibility, greater than equal to 0 also possibility. So first is not vector space. Second, not vector space. Non-zero have direct same. 0 also possibility. Here also addition of two matrices, determinant is 0. Non-zero matrices are there. But there we can just you think identity and minus identity. So, okay, second is correct. Third, trace of A plus B, trace of A plus trace of B, lambda any scalar into trace 0 only will. Third is correct. Fourth also correct, trace is non-zero, no problem. Correct. Remaining are correct. One mistake told, remaining are correct. But multiple choice means marks can't get because of your little mistake. This. Rank and trace both are equal. Identity itself take and identity take. Identity matrix 3 cross 3 matrix, suppose n cross n, 3 cross 3, rank is 3, trace is 3. But what about minus identity? Belongs to W. Rank is 3, trace is minus 3. Okay. So does not belongs to W. Okay, now correct. Another anything? Both are movie theater type movie sing, but movie not understanding. Movie get more confused. Some discussion will go. No. Both are different types. Understanding of that. புரியலையே understanding. Some adjustment going on. Exam hall like that have to do. No time. Direct tick, 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 tick have to do. Any problem there, both of you? Any confusion? Tell. Into determinant of AB, that is multiplication. No, this is addition. Jonathan, what happened? Understanding or not?
Sir, option C, can you explain once?
Option C. This is no problem. Both property addition, scalar multiplication, both will satisfy. Suppose A comma B belongs to W, then trace of A 0, trace of B also 0. So implies that trace of A plus B under addition closed. So trace of A plus B is equal to trace of A plus trace of B. So 0. And scalar multiplication also will satisfy any type of A from field, trace of A into A. So trace into lambda A, I gave lambda. Anyhow, for all lambda is 0. So must will satisfy both property. Under addition closed and under scalar multiplication closed. So this is a vector space, subspace. Roshika, what problem? Understood? No. Confirm. Leave day, why not coming? Hospital, health not good. Not today, okay, no. Try to come. Give more time here. Here you will give time, you will feel changes more. Come and read. Without your hard work, result not possible. Always keep in mind, I am not giving result. Your result 100% only because of you. Keep in mind. No hard work, no result. Finished everybody, I will go next. Understood? Already I explained. No problem. Very important is still this and all repetition coming. Still, if question will ask or won't ask, in between, no, this theory is asking. You will see in between any options or any big theories have, but in between this used have. Very, very important, these two statement. And very means concept is, I'm old only, that I'm not telling. Means just to think before 30, 40 years also they asked, now also they are asking. Right, first then I will explain. Very important theorem. Finished. So intersection of subspaces must be subspace. Just this is basic proof. W1, W2 subspace given have. Then I went same under addition closed, under scalar multiplication and addition both closed. So A alpha plus B beta belongs to W1 and A alpha plus B beta belongs to W2. When vectors are belongs to W1, W2, then intersection point must A alpha plus B beta form only will come. So whatever vector will come, that also A alpha plus B beta. So for all alpha beta belongs to W1 intersection W2, A alpha plus B beta belongs to W1 intersection W2. So that is the subspace. Okay. Union of subspaces must be subspace. Question mark. Counter example. 1001. Vector not asking, vector space. That time also vector space asking, element telling. You tell me R3 I am understanding. Ninge solpa. R. Tell. Add means there 1 comma 1 belongs to R square only. I will tell means then you will get upset, angry, everything. And half answer giving, wrong answer giving. Thinking correct, answer correct not coming. You will tell anything? Anything tell? Won't tell anything. Today what happened for you? Full silent man. Today she is telling mistake. Any transferred? Interchange to each other? Ama. Oh, so maybe know that rule regular what nature interchangement. Yeah, they are shocked. From morning they are thinking what is going on. You are correct only. Basically, you are telling 1001, don't tell. You tell W1 is A comma 0, W2 is 0 comma B. Then their union not possible. Like that tell 1 comma 0, 0 comma 1, add not possible. Add means 1 comma 1 belongs to R square again. Why not possible? W1 choose X00, W2 0 comma 0. Sorry, 0 y 0. R both are subspace of Q over the field R. So their union W1 is W2. Union means what? Just collection we can write. means x comma 0 comma 0 and 0 comma y comma 0, like these elements are in form. So just closure law itself won't satisfy. Suppose 1 0 0 0 1 0 belongs to W1 union W2, and the addition 1 1 0, and this does not belongs to W1 union W2. So W1 union W2 is not subspace. So for this writing may or may not be subspace. But subspace also will happen. May or may not be also don't want. We will see which case. Right first. You both know now these are basic going on, but I don't know from which space you came. But now I'm feeling no, you both are on Mars, miss other space. I'm feeling like that. Both are pure shocked, and now these are no very basic linear algebra. Very big and very bad concepts are there. Too much head pain will come. Too much thinking, all and only theories. In matrix, at least calculating, seeing in between question, solution, rank, fang, only theories you see everyday class. Revision time, extra like that example think, same don't memorize. Extra think. Other W1, W2. Boring, no? Today for you, both. Both are boring feeling. Pray God and come linear algebra class. Otherwise problem will come per day. Huh? Okay, finished. Union is also subspace. If and only if intersection of subspace is non-abelian, non-empty. Intersection of here, what is the meaning of non-empty? Two subspace intersection, empty, non-empty, no need to tell first. Set means empty, non-empty, telling means no problem. Intersection must will come empty, must will come any element, and that is called as zero. Non-empty means what? Either zero or more than elements. That is the meaning, but not like that. That is not correct. Intersection of subspaces must be subspace. What is the meaning? At least one element will come, that is zero. And any vector subspace containing at least one element, that means that is a zero vector. Huh? We know on set chapter, or you saw maybe your 11, 12 class common, disjoint set, non-disjoint set. Disjoint means what? Intersection will be empty. Non-empty means non-disjoint. But here disjoint subspace we will see in future, not now. Disjoint subspace means non-empty only, but zero vector will come. Here disjoint subspace means zero subspace. Okay? In subspace intersection must zero will come. So here will come if and only if. This is also very famous theorem on BSc, MSc. If and only if anyone is contained to other. Means W1 containing W2 or W2 containing W1. If not containing, not subspace directal, because this is if and only if. Union is not subspace if not containing to anyone is other. Containing means must subspace. So we will prove this, and proof means what? This proof also we will do contradiction. No proof is there. By contradiction we will prove. So we will go necessary condition. Necessary condition only lengthy. Sufficient is no problem. Means given have W1 union W2 is a subspace. Then we have to prove W1 containing in W2 or W2 containing in W1. We have to prove this is. So we will prove by contradiction. Means just suppose that this does not containing here or this does not containing here. Okay, if W1 does not belong to W2, this meaning any elements I am choosing from W1 that does not containing in W2, and W2 does not containing in W1 means W2 elements does not containing in W1. But I can write that alpha and beta both containing in union. Union no problem. But I can write alpha, beta both can contain on union case. Which just you think implies that separate also can write. But alpha must belongs to this, beta must belongs to this. Union, no problem. Any problem? And what is union? Subspace. Since W1 union W2 is a subspace. When subspace have and alpha beta belongs to W1 union W2 have, so I can write alpha plus beta belongs to W1 union W2. Suppose equation 1, equation 2, equation 3. Okay. Hereafter I will go 1, 3, 2, 3. Means just if alpha, here I can write implies that hereafter, 1 minute. Alpha plus beta belongs to union have this meaning alpha plus beta belongs to W1 or alpha plus beta belongs to W2. Anyone? This I don't want. This I want. This equation 3 choose. So alpha plus beta either will belongs to W1 or belongs to W2. Here after 1, 3, 2, 3 we will go. So by 1 and 3 means if alpha belongs to W1 have and alpha plus beta belongs to W1, then implies that I will use additive inverse and I will add after that. Means just you think alpha plus beta minus alpha belongs to W1. Closure law also using, inverse also using. Alpha belongs to W1 means minus alpha belongs to W1. Minus alpha plus beta belongs to W1. Minus alpha plus alpha cancel, beta belongs to W1. But what is beta? Does not belongs to W1. So this is the contradiction. So by equation 2, this is contradiction. Same we will use now by equation 2 and 3. By 2 and 3. If beta belongs to W2 and alpha plus beta belongs to W2, then same alpha plus beta minus beta belongs to W2. Again alpha belongs to W2. What is alpha? Does not belongs to W2. So by equation 1, this is the contradiction. So finally, our supposition was wrong. When contradiction telling, this meaning wrong we choose, wrong came. So our supposition was wrong. So finally, W1 must containing W2 and W2 must containing W1. I have no place. Finally, W1 must containing W2 or W2 must containing W1. So hence the result, means W1 union W2 subspace, then must containing any one to each other. Okay, right. Finished everybody? Right first. Finished everybody? After this wrote no, hence the result. Okay. Next, sufficient condition. Sufficient is easy only, just one line answer. Subjective exam, whenever we'll write, either write statement again on after proof, otherwise hence the result must write, otherwise the number will cut. Sufficient condition means if W1 containing in W2 or W2 containing in W1, then union must be subspace. So one line answer, suppose W1 containing in W2, then W1 union W2 is W1, then finish. And W1 is subspace, so this is subspace. My belief don't damage. W1 containing in W2, then W2, whatever. Okay. So this is subspace. So this is subspace. Same W2 containing in W1. Then W1 union W2 is W1. So this is subspace. So that is subspace, finish. Hence the result. I have belief with you. Don't damage that is. So finally finished. Union, whenever subspace you will see, then anyone must contain to other. Must. Not containing direct, right? Cancel. Not subspace. Okay. After lunch. After lunch, hereafter, huh? Prasadam giving. Go and eat everybody and come. Huh? For that living. Okay, then after lunch, read, lunch and I'll take and read, everybody. Revise notes and I'll, time pass don't do. I thought some question will do. Okay.